This video is on the objective identify and explain differences between one and two-tailed hypotheses tests. So this is number 2. Okay, this is the second video on a question related to this objective that I'm doing from your Newton Ulta homework. So hopefully you've seen the first one. So I'm going to go through an explanation again, but take a little less time on it this time. So I'm going to go to some paper first. Remember, first I'm going to talk about, how do we know, right? How do we know if we're performing what's called, a left-tailed test or a right-tailed test or a two-tailed test? And it all has to do with how the alternative hypothesis looks. So remember, you got to claim some sort of statement that you're testing, some sort of statement that's being made about a parameter, about some aspect of the population, like mu or p. And then from that claim, you form hypotheses. The null hypothesis, which always involves equality, that the parameter is equal to some value, which they'll be using the equals all the time here. You could have greater than or equal to or less than or equal to as well, but in this book, it's always going to be just that the parameter equals a specific value. And then the opposite of this is the alternative hypothesis, and it's how the alternative hypothesis looks that determines what kind of test you're performing. Right. So if you do, there's an N in there, sorry, alternative hypothesis HA, again, doesn't involve equality, so you could have the parameter is not equal to some value, parameter is greater than some value, or parameter is less than some value. If it looks like this, with the parameters not equal to some value, that's a two-tailed test. If the parameter is just greater than some value, that's a right-tailed test. And if the parameter is less than some value, that's a left-tailed test. All right, and in the first video for this objective, I also went over all the differences between them. Like, I'll just very quickly brush through these again. So when you're performing a left-tailed test, and remember there's two different types of approaches to a hypothesis test. There's a critical value approach and a p-value approach. Now, if you're doing the critical value approach, first you find the test statistic for your sample, and then you find that critical, you're going to have a distribution, a sampling distribution, whether it be a normal distribution or a student's t-distribution or whatever. And for a left-tailed test, your critical value is whatever value on the number line has an area of alpha to the left. Alpha being the significance level. And if the test statistic is less than or equal to the critical value, that means you're in that rejection region. You reject the null hypothesis. If the test statistic is greater than the critical value, you aren't in the rejection region. You fail to reject the null hypothesis. And then you had, if you're using the p-value approach, you just take your test statistic, find the area to the left, that's called the p-value, and then compare the p-value to the significance level alpha. If the p-value is less than or equal to alpha, you reject the null. If the p-value is greater than alpha, you don't reject it. And I had stuff for the right-tailed tests and two-tailed tests last time in my first video. I'm not going to go over that again here because it's not really being asked about here. I'll go over that stuff again in another video where we're actually on an objective that is related to that. Alright, so looking at the question. So it says here, an assistant lecturer at the sociology department of a university claims, there's your dead giveaway right there, there's your claim, claims that the average amount of time adults spend on social media daily is less than 3.6 hours. If the assistant sociology lecturer wants to conduct a hypothesis test, should they use a left, right, or two-tailed hypothesis test to analyze whether the average amount of time adults spend on social media daily is less than 3.6 hours? Alright, so this is about an average, about a mean. So, let me show you here. So the claim, right, what this lecturer claims is that, I'll say mu for mean, right, an average. say mu here represents the average amount of time adults spend on social media daily is mu. And their claim is that this is less than 3.6 hours, or just less than. Now notice that this does not involve equality, so that's going to be the alternative hypothesis. And then the null hypothesis would be that mu is, the opposite of this, greater than or equal to 3.6 hours. But in this book, we're only going to use the equal part. All right, because that's what's going to be assumed when we do testing. But the one thing that matters most for this particular question is how the alternative hypothesis looks. It is my parameter mu, this average number of times spent on social media daily, is less than 3.6. It's a less than, the parameter is less than a certain value. So we'd be performing a left-tailed test. And that's all they're asking, I think. Let's see. So left-tailed, and I don't remember if there was a second part to this. Let's see. Yeah, there is a second part, right? So here, a sociology professor who teaches at the same sociology department of the university thinks adults spend a different amount of time on social media daily. The sociology professor would like to carry out a hypothesis test and test the claim that the average amount of time adults spend on social media daily is different from 3.6 hours. Now, why is it two-tailed? Because different is, not equal. Their alternate hypothesis, or their alternative hypothesis, would be that mu is not equal to 3.6. So it can be on either side. That's why it's two-tailed. Because no direction is specified. Not greater than, not less than. All right. When no direction is specified, it's two-tailed. Now, if they said greater than, it'd be right-tailed. They said less than, it'd be left-tailed. But different from is neither. Neither direction is specified, so you can be on either side. Wonderful. And that looks like it for that. But so yeah, hopefully this video helps. These past couple help when you're looking at questions like this about what kind of a test is being performed: left-tailed, right-tailed, two-tailed. And don't forget, right? It all depends on how that alternative hypothesis is looking. So hopefully you can set up your hypotheses correctly. All right. And thank you very much for watching.